In this video, we're going to talk about rational exponents. Rational means, like, it could be written as a fraction, it's a ratio. And so rational exponents mostly just means exponents that are fractions. And kind of the short answer here is these are actually radicals. And I know they don't look like it, but you write things in math many different ways sometimes. For example, if I had x divided by 2, or 1/2 x, or 0.5 times x, you guys know that all three of these things mean the exact same thing. They're all just taking x and taking a half of it, but it's written in different ways, as a decimal or as a fraction, but it means the same thing. So radicals and exponents are basically the same way. They're kind of the same thing, they're just written in different ways. So go ahead and take a look at this. So this is some rational exponents and radicals that actually are the same. See if you notice a pattern here. Alright, so what you may be noticing is that whatever the bottom of the fraction is, whatever that denominator is, actually becomes the index of the radical. So, like 7 to the 3/4. The 7 to the 3 power, that stays, but this 4 on the bottom, you could actually rewrite it as the 4th root of 7 to the 3rd. Or if you wanted to rewrite this in exponent form, you could leave 7 to the 3rd, but make the 4 be part of the fraction and the denominator. If I want to rewrite this, 8 to the 2/3, I'll leave 8 and the 2 as they are. But the 3 can be rewritten as a radical. By the way, that radical can go over just the 8, or it could go over the squared part as well, just based on whatever feels easiest for me. Either way will work. In this case, I'm going to just put it over the 8 because I know the cube root of 8. The cube root of 8 is 2, because 2 times 2 times 2 is 8. The squared is still there though, but 2 squared is 4. So I actually just simplified 8 to the 2/3 power is 4, and I didn't even need a calculator for that. So here's kind of the rule, just kind of in general. If you have an exponent that's a fraction, again, you can rewrite it as a radical, where whatever's in the denominator of the fraction becomes the index on the radical, the number in front of the radical. And once again, that can go outside, the power that's left can stay inside the radical, or it can go outside the radical. It actually doesn't matter. So we're going to go through a few examples here. And just to be clear, sometimes it's easier to have the exponent as a fraction, and sometimes it's easier to have it as a radical. It really just depends on whatever your problem is. So maybe try both and see, just if one way doesn't work, try it another way. And this one, I have no idea what 49 to the 3/2 power is. I could put that in my calculator, but I could also do it by hand if I just rewrite this as a radical. So the 2 becomes the index, and the 49 cubed stays. I'm going to put the cubed on the outside because I don't know what 49 cubed is. But I do know the square root of 49. It's 7. And then I can do 7 cubed, which you may need a calculator for that. I think it's 343. Yeah, 343. And so there we go. Alright, here's a couple more. Go ahead and pause the video and try these and see if you can do them on your own, and then watch me do it. Alright, so in this one, the 2 becomes the index of the radical, and the 9 to the 1st power stays. In this case, I'm just going to do 9 to the 1st power is just 9. So the square root of 9 is 3. By the way, if anything is ever to the 1/2 power, that's the same as just saying the square root. Because if you make 2 the index, that's the square root. And if there's a 1 left over, anything to the 1 power is itself. So a 1/2 exponent is basically just the square root, a regular little square root. All right, let's do 9 to the 2/3, which would be written as 3 as the index, and then 9 squared stays. I don't know the cube root of 9, so I guess I'm going to do 9 squared first. So 9 squared is 81, and then we can do the cube root of 81, which, let me just make sure. Oh, it doesn't come out even. So we'll just leave it, the cube root of 81. And this one, we're going to have the 4, and then we'll leave 9 cubed. I'm just going to rewrite these. And then this one, we would move the 5, and we would leave 9 squared. All right, this time we're gonna, if you have multiple things to a power, they all go under the radical. So all of this would go under the radical as 2x to the first power, and the 3 gets bumped out here. You don't really need to put the 1 there, so I'm just gonna rewrite this as the cube root of 2x. Notice that anything to the 1/3 power is always gonna be a cube root. However, this is different from what we just did. In this problem, only the x is to the 1/3 power, and then it's times 2 because of order of operations. So in this one, the 2 will just have to hang around outside, but when I rewrite this, I'm going to rewrite that as the cube root of x to the first power, which is just x. And so it's 2 times the cube root of x. All right, let's see if we can do this one without a calculator. Again, I don't know what this stuff to the 2/3 power is, but let's rewrite it as a radical and move the 3 out as a radical and do 8 over 27 squared, leaving the 2 there. Remember, you can break radicals up if it's just division. So I could do the cube root of 8.
You can come on the front office when you get a chance.
And the cube root of 27, and I could square those both. The cube root of 8 is 2, and the cube root of 27 is 3, which would be 4 over 9. Again, all without a calculator. Here's just a few more examples. On this one, it might actually be easier to rewrite it as a fraction, because I might not know what the 5th root of that is, but if I rewrite it as a fraction, I'll leave x to the 50th there, but 5 goes on the bottom of the fraction, which is x to the 10th. And now it's simplified. On this one, I can rewrite it as x to the 6th and put that index on the bottom. Be careful if there's not an index written, it's actually a 2, remember, it's a square root. So divide the 6 by 2 and you get x to the 3rd. On this one, we've got a to the 6th, but divide it by 3, and you're left with a squared. On this one, remember 1/2 is actually just a square root, because the 2 gets bumped to the index, and then 16 to the first power is just 16, and then the square root of 16 is 4. This is really just a cube root of 1,000, because the 3 gets bumped to be the index, and then 1,000 to the first power is just 1,000. The cube root of 1,000 is 10, because 10 times 10 times 10 would be 3 zeros. So. All right, let's do a slightly more complicated one here. Remember, you don't want to have radicals on the bottom of a fraction in the denominator. So to simplify this, I want to get rid of that radical. And there's a few ways to do this, but one way would be to do what we just talked about. I'm not going to be able to combine these as they are because that's not a radical. But if I rewrote this as an exponent, then I could just use exponent rules. So what I mean by that is, rewrite this, and remember there's a 1 here. So rewrite that as 5 to the 1/3 power. The power on this one is just a 1. And remember, if you have the same base, all you have to do is subtract their exponents. So this simplifies to 5, and then I just do 1 minus 1/3. which would be negative 2/3. Sorry, no, positive 2/3. Because that's 3/3 minus 1/3. And then if I wanted, I could rewrite this back as a radical. So move the 3 as the index, leave the 5 squared, and that's the cube root of 25. This is technically simpler than what we started with because there's not a radical on the bottom anymore. And so cube root of 25 doesn't come out even, so I'll just leave it as it is. Here's another kind of weird one here. I'm aware you could do this in your calculator, but let's try to simplify it without. By the way, this is not minus 1/5, it's to the power of negative 1/5. So use what we know about exponents and basically multiply both of these by negative 1/5. So I've got 4. 5 times a fifth would be 1, and it's negative, so it's negative 1. And then I've got another 5 times negative 1/5, which is also negative 1. Remember, if an exponent is negative, the way you make it positive is you flip it to the bottom of the fraction, or the other side of the fraction. So this is going to be 4 to the positive 1 and 3 to the positive 1, but they've got to move down to the bottom of the fraction, and then we'll just put a 1 as a placeholder up top. And now that's just 4 times 3, which is 12. So this whole thing just turned into 1/12. This one's pretty complicated as well, and currently I've got like cube roots and square roots, and I'm not going to be able to combine all of that, but I can if they're exponents. So let's rewrite them all as, or at least the 2 pieces of the numerator as exponents. So I've got x to the 1/3 times x to the 5/2. And all of that is divided by this stuff. This stuff actually square roots. Square root of 25 is 5, and the square root of x to the 16 is x to the 8. If you weren't sure about that, just do 16 divided by 2. Okay, let's deal with this stuff on top now. Remember, when you're multiplying, you just add the exponents. So I need to do 1/3 plus 5/2, which would be, let's make these 6. So that's 2/6 plus 15/6, which would be 17/6. So all of this becomes x to the 17/6 over 5x to the 8. Now I can combine these by subtracting the exponents. I'm going to go ahead and just use my calculator on this. I'm going to do 8 minus 17/6. And it gives you 31/6. So this is 5x 31/6. I know it looks kind of complicated, but it's at least simpler than what we started with.